Okay, we'll go ahead and get started. I'd like to thank everyone for joining this afternoon. This is the second part in our three-part webinar series regarding NetBackup. My name is Christian Muma. I'm the lead of our data protection practice here at NetX. On the line as well, I have MJ Johnson, who's our National Account Manager, and Angelo Shasha, who is our Senior Vice President. Before we get started, I have one slide just to give you a little idea about NetX and who we are. We like to consider ourselves an engineering company first. We do help architect, implement, design. We do upgrade services, things of that nature. Each of the practice leads for the different areas that we cover has at least 10 years of consulting experience. Myself, I have 11 years of consulting experience with NetBackup and some storage thrown in there as well. So all of the products that we resell, we have the knowledge and expertise to implement and troubleshoot and help with professional services. We're dedicated to a single partner in each technology area. When I first started with NetX earlier in 2015, we only supported Symantec. Naturally, with the split between Symantec and Veritas, we became a two-vendor reseller. And then late last year, we got on board with the partnership of Pure Storage. And now we're happy to offer their storage arrays and services as well. So that's a little bit about us. Today, we'll be talking about the NetBackup 5330 appliance. Periodically take a peek in the chat window. So if you have any questions, please put them in the questions portion of the chat window. And if for some reason I miss your question or for whatever reason we skip over it, feel free to respond to the email that comes out after the webinar, and I'll make sure to get all your questions answered. So today we'll be discussing advantages of appliance-based backups, the differences between the two models that Veritas offers, the 5330 and the 5230. We'll discuss a little bit of why you would use a 5330 over 5230, or actually why you would use a 5230 over 5330. We'll take a brief look at a hardware overview. We'll look at the software that runs on the NetBackup appliances, and we'll take a look at the different configuration options you can order an appliance, as well as the sizing and specifications. And lastly, we'll wrap up with a new feature of NetBackup known as CoPilot for Oracle, which is pretty interesting as well. So, advantages of appliance-based backups. The biggest advantage is highlighted at the top of this slide, where appliances eliminate the complexity of backups by delivering an integrated solution. So those of us that have been around NetBackup for a while remember back before Symantec or Veritas released minimum requirements for servers, and you had to do your homework to appropriately size or configure a master server or a media server. They're a little bit better with that now. There are some minimum requirements, but there's still a lot of homework and research that needs to be done when you select a server model, as far as, do you want more CPU power? Do you want more bus plane? What is the role the server going to be? So it's a little bit complicated. But with an appliance, you get rid of all that because they come maximized for their specific purpose. They're built to be performant for backups. Along with that, they're easier to scale as your data grows. You get enhanced resiliency, so there's a lot of redundancy built in the appliances that you wouldn't have to worry about if you're ordering a home-built server. They provide flexibility with performance, so you can scale for either capacity or throughput, and they deliver operational efficiency and insight. Some of the software that comes on the appliances is much more robust than what you would get from your traditional HP or Dell hardware manufacturer. So first we'll take a look at the differences between the 5230 and the 5330. This slide, the first thing you'll notice is the difference in capacity. 5230 comes as a compute node with at least 4 terabytes of storage on it, although you can get a 14 terabyte model. From that, you can add 36 terabyte disk shelves and expanded all the way out to 148 terabytes. The 5330 comes with the compute node and at least one storage shelf, referred to as the primary storage shelf. The storage shelves for the 5230s come with 16 disks, and the storage shelves for the 5330s come with 60 disks. On the 5230, the storage shelves are connected with SAS connectivity, while on the 5330, it's fiber channel. And the 5230 has internal RAID controllers inside the compute node, whereas the 5330 has RAID controllers inside the storage shelves themselves. Both models use RAID 6. So what that means is the actual write computations from the RAID controller themselves is externalized in the 5330, whereas the 5230, it's built in and it's a less performant model. It's also redundant on the 5330. All right, so here's some hardware differences between the compute nodes. This is looking at the compute node from the front. You can see each one comes with 12 disk bays. The 5330 has mirrored volumes in drive 0 and 1 with the hot spare in drive 2. That first mirrored volume is for the operating system. It's referred to as the boot drive. And then secondly, there's a mirrored volume with drives 3 and 4 that's used just for logs. And then another hot spare in slot 5. And then the disks in slots 6 and 7 are reserved for future use. So that's in case Veritas comes out with features later that require more disk space. All models of 5330s will already have those disks in there. So contrary to that, on the 5230, you have drives that can be used to actually store backups. So this is what we were showing on the last slide, where you can get either 4 terabytes or 14 terabytes. This has a mirrored RAID set for disks 0 and 1 that contain both the boot volume and the drives, and there's only one hot spare in slot 11. All right, some other differences inside the compute nodes. The 5330 is much faster. It has 2 Xeon 10-core, 3 gigahertz processors. They all come with 384 gigabytes of memory. So it comes with enough memory to expand to the maximum amount of storage. Whereas with the 5230, you would get memory modules as you expanded storage. All expansion slots in the 5330 are already populated. So later on, we'll take a look at the different configurations available, but they're all there. You can swap them out later. So if you go with a configuration that has more Ethernet than fiber channel and you decide to change that later, you can change it as long as it still conforms to one of the supported configurations. And with those configurations, you can get up to 8 gigabit fiber channel ports or 10 gigabit Ethernet ports. So on this slide, we see the differences in performance between the 5230s and the 5330. The first thing you'll see is the number of streams for the ingest rate. So with a 5230, you don't really want to go over 120 streams or 120 concurrent backups. You can see as you scale the 5230, the performance increases with the more spinning disks you have. Whereas on the 5330, it's pretty much the same if you have 1 or 2 storage shelves. But you'll notice a dramatic increase going from 120 streams to 500 streams, and the maximum ingest rate for a 5230 is about 20 terabytes an hour, whereas on a 5330, it's 140 terabytes an hour. So we can see a fairly big difference there. Another significant data point on this slide is the restore rate. So you can see where a 5230 maxes out at 1.16 terabytes per hour, whereas a 5330 can go up to 4.6 terabytes an hour. That's relevant not just for restores, but for duplication to tape. So if you still have a need, even though you're backing up to disk, still have a need to vault to tape daily, for offsite retention or whatever your needs may be, a a 5330 may, just for that fact alone, be a better reason to choose a 5330 over 5230. And then along at the bottom, you'll see the rack space. The fully populated 5230 with 4 disk shelves takes up 14U and is 144 terabytes, whereas the 5330 can fit 458 terabytes in 10U, which is very dense. I haven't seen anything from any competitors to the NetBackup appliance that can achieve that density in rack space. Now we'll talk about the differences in roles between the 5230 and the 5330, and this kind of plays into why you would choose one over the other. The 5230 can serve as a master server or a media server, while the 5330 is only a media server. So you would see a 5230 in small and medium-sized environments. You can have one standalone appliance. So, you know, if you only need 40 terabytes of storage, you might be able to use just a 5230 as your master server and your media server. I've certainly seen plenty of configurations that work fine in that regard. You could also have a 5230 as just a master server with the 4 terabyte model, and then use 5330s as your media servers in your storage pools. 5230s are great for smaller remote offices. So if you need something to back up files in your satellite offices and then use optimized replication to move that data back to your centralized office or your central data center, 5230s are usually a good choice for that. Or if you have segregated networks, so maybe you only have the need for, say, 60 terabytes of backup data, but it's spread across 4 or 5 segregated networks, it might make sense to go with a smaller appliance. And that's useful in multi-tenant environments. We've seen that quite a bit. The 5330, obviously for large environments, when you need more capacity, you would go with the appliance that has the most capacity. They're useful for as a many-to-one replication target. So the scenario I was speaking of a moment ago, where you have multiple satellite offices with 5230s, you could have them all replicating back to a single 5330 at your central data center or your secure offsite recovery facility. They're excellent for daily duplication to tape, as I mentioned earlier, because they have that faster restore rate. And along the same lines, if you have a critical recovery time, the 5330 might be the better choice as well, because you get that 4.6 terabytes an hour as opposed to the 1.1 terabytes per hour on the 5230. And then naturally, with 500 concurrent streams and the much higher ingest rate, 5330 would be a good choice if you have really tight backup windows and need to finish your backups quickly. One other thing we talked about a little bit before are everything on a 5330 is fully redundant. So there are 2 RAID controllers in the storage shelves that we'll see later on, and each storage shelf is redundant, and we'll take a look at that and how the disk is laid out too. So this is a high-level overview of the hardware. As mentioned before, there's a compute node, and with the 5330, you need at least one storage shelf, and that's referred to as a primary storage shelf. You can get that shelf at 114 terabytes or 229 terabytes. So the range of storage is 114, 229, and then you can have 2 229 terabyte storage shelves equaling 458 terabytes. If you already have a unit with 2 114 terabyte shelves and you want to move to 458, you can actually add a third shelf that is supported. So you could add a third 229 terabyte shelf, but you can't have 3 229 terabyte shelves, unfortunately. There's up to 8 gigabit per second fiber channel ports and 10 gigabit per second Ethernet ports. The storage shelves are connected via fiber channel, and the RAID controllers are in the shelves themselves, in the primary storage shelf. As mentioned before, fully redundant paths and 458 terabytes of usable storage in 10U of rack space. So here's a view of the back of the 5330. As I previously mentioned, all the slots come pre-populated. You'll notice PCI slot 1 and PCI slot 4 have asterisks next to them. Those come with fiber channel cards that have to be used for the primary storage shelf. The customizable configuration is only for PCIe slots 2, 3, 5, and 6. And at the bottom of the slide, you can see the different configurations that are available. So option A has all 4 of the expansion slots with 1 gigabit fiber channel ports, or excuse me, with 10 gigabit Ethernet ports. So there's 0 fiber channel ports on option A, and then it slowly swaps out 1 card as you get all the way to the bottom where you have 8 gigabit fiber channel ports. And then the 2 10 gigabit Ethernet ports are the onboard ports that you see in the lower right-hand side of the bottom of the machine. As I mentioned earlier, you can, if you start out with all Ethernet ports, you can switch it to add fiber channel ports, but you have to maintain one of these configurations. So you can see that if you start with option A and you have 10 gigabit cards in the 4 expansion slots, to add a fiber channel card, you would start with slot 6. And then if you wanted 4 fiber channel slots, or 4 fiber channel ports, you would go slot 6 and slot 5. All right, now we'll talk a little bit about the storage shelves. So each 5330 comes with at least 1 storage shelf. They're actually NetApp disk arrays. So if you're familiar with NetApp, the platform in that frame might be a little bit familiar looking to you. The primary shelf, which is the first one, contains 2 redundant RAID controllers, and they're connected to the compute node via fiber channel. It's just regular LC to LC cables on the back going up to the top. And then any expansion shelf after that would be connected to the primary shelf via SAS. So the expansion shelves don't have RAID controllers of their own. They rely on the RAID controllers that are in the primary shelf. There are 5 drawers in each shelf, and each drawer has 12 disks in it. And using Volume Manager, it stripes 6 volumes for each expansion shelf. So in total, you could have 12 if you had a primary and a secondary storage shelf. And everything is striped with RAID 6, and all the components, including the drawers themselves, are hot swappable. So if whatever's connecting the drawer to the backplane of the storage shelf, something happens there, you can actually swap out the whole storage, the whole drawer of disks and not lose any data. This is a view of the back of the storage shelves. On the top, we have the primary shelf. You can see it has, right in the middle, the 2 RAID controllers. Each one has 2 ports that go to the compute node. There's also USB and Ethernet ports because they are NetApp devices, but they're unused, and you can't do anything with them as a NetApp, or excuse me, as a NetBackup appliance. At the bottom, you see the secondary shelf, and there's no fiber channel on it, only SAS ports that connect back up to the primary shelf. And again, the Ethernet ports on here are unused. So here we'll take a look at how the RAID configuration is set up. You can see each color in this diagram represents 1 volume. 1 rated volume. So each RAID set only has 1 or 2 disks on each shelf. So that's why, because it's RAID 6, you can lose up to 2 disks and still maintain data integrity. That's why you could lose an entire storage shelf and still not lose any data. And then at the bottom, the 2 front disks on each shelf are reserved for metadata, and that's basically the meta base for the pure disk deduplication engine. And then we have hot spares on the top and the bottom shelf. So we'll go talk a little bit more about the volume configuration. As I mentioned, each RAID 6 set is represented by a LUN that's presented to Volume Manager. The MSDP disk pool is comprised of all the RAID 6 logical volumes. So typically, if you installed a media server on your own hardware platform, or if you're using a 5230 appliance, you can only have one volume to use as pure disk storage, as a deduplication pool. The only exception to that is on the 5330 appliance, where you get 6. And the reason for that, you can see at the bottom here the advantages to it. The first one is parallel CRC checking. So when the background maintenance is performed and Pure Disk is making sure that it has all the data that it's supposed to, it can do it on 6 different volumes at a time. So it's 6 different streams, basically. It also reduces file system check times. So if you have to run FSCK, that's certainly much faster to do 6 streams in parallel than it would be one giant 458 terabyte volume. And the same thing goes for ingesting data, which is why you get such higher input and restore rates, are because you can do that with 6 streams in parallel to 6 different file systems. That also allows us to get around the sizing, the file system limitations in Linux. Now we'll take a brief overview of the software that comes on a 5330 appliance. So for daily administration, you would use the Appliance web console or the Appliance CLISH. To manage your backup jobs, you would use the good old NetBackup Java console. And then in the CLISH or through SSH, you can also use NetBackup CLI. So if you're used to more command line administration, you can open an SSH session directly to the appliance and run NetBackup commands. The web console, which is in the bottom right, is mostly used to manage hardware or specific things about the array. So you can configure your storage pool through the web console. You would assign an appliance role, although the only role available on a 5330 is a media server. You still have to go through that step. And then, of course, you can use the web console to manage the hardware, look at alerts. You can use it for user administration. Anything you want to configure for alerting or NTMP, email, stuff like that would all go through the appliance web console. You could also use it to collect logs and support packages in some NetBackup configuration settings, things like buffer settings. There's a very few NetBackup parameters that you can change through the web console. CLISH supports everything that the web console does just through command line. So you can monitor and manage the appliance, perform user administration tasks, set up the same thing with alerting or NTMP, stuff like that, managing the operating system itself. And here you can collect logs, pretty much all the same thing, except you can now perform the NetBackup commands in a little bit more in-depth troubleshooting. So as I mentioned earlier, everything that you can do through the web console, you can do through the CLISH, and there's a few things you can do through the CLISH that you can't do through the web console. Usually when a new command appears, you'll see it in the CLISH prior to the web console. So the NetBackup Administration GUI, most of us are familiar with. If you're a NetBackup user, this is what you look at every day. and it's where you monitor and manage backups. You would use this whether you use an appliance or not. You can configure the storage, your policies and lifecycle policies, kick off backups, manage your tape devices and the NetBackup catalog. Pretty much everything you do for NetBackup as a daily administrator is done through the GUI. So here are some of the less obvious things going on in an appliance, the background components. The first one is VMware APIs, which are used to mount and back up the VMware snapshots when you're using VADP or vSphere backups. That's simply a library that's supplied by VMware that NetBackup uses to be able to interpret the file system or make a connection with NVD to the ESX data stores. There's a SymCLI are the commands for the NetApp array, so you'll only see that used on a 5330, and you would only use that if you had a support case open and you were troubleshooting a problem with the array itself. MegaCLI is the counterpart for the internal storage arrays. So on a 5330, that would only be for the boot volume or the log volumes. On a 5230, you would use that for the MSDP disk as well. Storage Foundation is running there in the background. As I mentioned earlier, that's how all the volumes are managed that are presented from the NetApp array. And it uses VXFS for file system and DMP for multipathing if you zone to data stores over fiber channel. WAN optimization is something that is automatically turned on, and most customers will never even know about or have to deal with, but it is there and worth mentioning. And it reduces latency and increases the integrity of TCP/IP transmissions. It's not really used for throughput, although you would think that from the name WAN optimization. Of course, the operating system under the covers, it was previously a SUSE kernel, and that's been changed to Red Hat very recently. SCSP is leftover from Symantec. Well, I shouldn't say leftover. It's used to harden the appliance. That's the two biggest features used on a NetBackup appliance are intrusion prevention and intrusion detection. It also prevents you from having root access by default. You have to overwrite that. PureDisk, most of us know, is the deduplication engine that NetBackup uses. So obviously that would be running in the background on a NetBackup deduplication appliance. And then HWMon is what monitors the hardware and runs the call home feature. So one feature of the NetBackup appliances is a call home, and that will send support alerts if a hardware component is failing, or if, say, there's a kernel panic or something wrong with the operating system. It immediately calls out to support and they open a case. And lastly is IPMI, which is a remote console, similar to the DRAC on Dell or ILO on HP, if you're familiar with those. Okay, so now we'll talk about one of the newest features of NetBackup appliances, which is CoPilot for Oracle. So at the base, CoPilot for Oracle is basically the appliance exporting an NFS share to Oracle servers. So previously, Oracle DBAs would dump their backup files to disk if you weren't using the agent. Now they can do that directly to the NetBackup appliance. And it provides us with a great deal of benefits. So it's a single shared pool of optimized storage. So it's one device that contains all of your backups, VMware, your file system backups, and now you can use it as a remote device to back up to as well without the NetBackup agent. It also provides the basis for accelerator for Oracle. This is a incremental forever type concept where you take one full backup and then after that take block-based incrementals and synthesize a full backup by rolling those incrementals into your last full backup image. And it uses the Oracle incremental merge without scripts. So it's all automated. You don't have to maintain shell scripts. And then lastly, their full backup images are synthesized inline. And this last point is deep Oracle integration. So while you're using CoPilot, you can still maintain an RMAN recovery catalog and perform your cross checks. So NetBackup knows what Oracle believes should be held on disk, and Oracle can check and make sure that NetBackup has what it believes should be held in its backup catalog. So here we have a diagram of the old method of using traditional dump and sweep processes to back up Oracle databases. And here we can see a database admin would sort of do a nightly database dump to disk. And then the backup admin would come along and back that up to tape or disk, and it would get deleted either through automation or cron jobs. We've seen all sorts of methods used to control this process. The problems with that are the DBA can't use backups that have already been swept up. So without going in purchasing a lot of disk, the DBA can only keep 1 or 2 backups on its server, or possibly get an intermediary device like a NetApp or an Isilon or something to store them on while they're getting backed up. But once they get backed up and removed, the DBA is now reliant on the backup administrator to perform a restore, and then the DBA can take that restore to disk and actually restore the database. Because there's only a couple kept on disk at a time, traditionally those have turned to full backups, which creates a heavy load on the database and takes a long time to do. So if you have a large database, you could be spending several hours a night just dumping that database to disk to get it as part of a file system backup. It also eats up resources in the data center, because now you have to transfer that to an intermediary and then transfer it from the intermediary to the backup software. So you're chewing up network, and you have to buy twice as much storage usually. Disadvantages for the backup admin with the old method is he can't verify that what his backup has is actually all the information for the database. So if it's automated through cron, we've seen a lot of times the backup might kick off before the database is actually finished dumping. So you get a partial database dump, and the whole file isn't there yet. And to the backup admin, it just looks like files. You can only go through and browse it as files. He also loses customization with the policies, so he can't really optimize it that well. So with CoPilot, you export an NFS share from the appliance, and the database admin mounts that on his database server and dumps to it directly. This can be achieved by the database admin scheduling these on his own, or it can actually be scheduled through NetBackup policies, where the NetBackup server would talk to the NetBackup agent, and it would speak to Oracle through Oracle's APIs and initiate that dump. And then NetBackup knows when that's complete and when it should be able to sweep it up. You gain quite a few advantages with this. First of all, the database admin sees and can use all of the database dumps, because he's looking at a mounted file system on a NetBackup server where they actually go. Reduces the production load, because now he doesn't have to do nightly dumps. He can do incremental dumps because they're no longer swept up and deleted every night. So that speeds up his nightly backups. Data integrity is preserved because we know that there's no mistimings. The backup doesn't start until the database dump finishes. We use much less storage because now we're doing incrementals, and it's going to wind up on the backup appliance anyway, so why not put it there first? Also with this method, as I mentioned earlier, we're able to use Accelerator for Oracle. So your incremental backups and your full backups can be just change blocks, and then the new full backup would be synthesized from those change blocks as well as the last full backup. Advantages for the backup admin with this are now he's aware of all the database operations. He knows when the database dump starts and stops, which database is on each one. He gets logs for all of that, so he's much more aware of the data that's being transferred. Those backups are distinguished from regular file system backups, so he can schedule them at different times or optimize the policies as his needs would be. And another really big advantage is since it goes directly to a NetBackup appliance, it's now incorporated with NetBackup lifecycle policies. So if you want to duplicate it to tape or replicate it to your offsite storage facility or your disaster recovery site, all that can be done immediately after the Oracle dump occurs. It's all completely integrated with NetBackup, and it's all cataloged in both RMAN and the NetBackup catalog. So we see a lot of uses for CoPilot. It's a pretty exciting feature. All right, so as we were moving along, I didn't see any questions pop up in the question chat. So I'll go ahead and pause here. If anyone has a question, let me know. Okay, I don't see anything popping up. As I mentioned at the beginning of the presentation, if you do have any questions or if there's anything that we didn't cover about the appliance that you'd like more in-depth information on, please respond to the email that comes out following this, this presentation, following the webinar, and we'll definitely get back with you and get you the answers that you're looking for. So I'd like to thank everyone for attending, and we look forward to seeing you in the future. Thanks.